Yes, you can start now.
Okay. A very good morning to one and all present over here. On the behalf of SRM Institute of Science and Technology, Solar Energy Society of India, myself, Dr. Samyaranjan Rautray, welcomes all of you to this webinar, Opportunities and Challenges of Solar Energy Storage. Today we have Mr. Prafullo Pathak, President, Solar Energy Society of India, as the guest of this program. Good morning to Prafullo sir.
Good morning. Good morning.
So I would like to request Mr. Prafullo Pathak to address the virtual gathering and enlighten the participants on the advantages of solar energy and its applications. Thank you, sir. Please.
Thank you, Dr. Soumyarajan. Very good morning to one and all. Before that, I would like to welcome Professor Senthil, who is our chief or who is our main speaker or the only speaker we have today. But it's a very happy thing or very pleasant thing which I want to communicate him that this is the first type of program we are starting, and he is the first person to address these type of series which we are starting. Solar Energy Society of India is a society which was having a background of academia, and as we all know that now the solar sector is for everyone. It is not to academia, it is not to research, it is for everyone. It is for trade, it is for the big projects, whatnot. Even it is by way of rooftop and other means, it is now going to be the part of everyone in our country, as well as we have an opportunity to take this knowledge in this infrastructure over the world, and that is a good business opportunity or entrepreneurship opportunity for the people, for the young generation. So keeping that in view, that solar is going to be a main area in next decade or more than that. uh, the Solar Energy Society of India has started concentrating on the students who are at the undergraduate level or postgraduate level, or those who have transformed them, the students who are transforming them from student to entrepreneur. So that is the one area which we have started targeting since last 2 years. Means since I have taken the reins of this Solar Energy Society of India, and uh, before March 20, we used to visit different institutions, universities, and we're trying to interact with the students one to one, to understand what is in their mind, to know, to guide them, to make them aware that this is the field or this is the opportunity which is coming in their way in coming decade. But since March 20, we all were confined to our rooms. But yes, we are human beings. We are not going to lose the things. We found a way. We started connecting digitally. The most advantageous system we already have. We were not knowing that this digital system, which we were trying to establish, will prove in such a big way to all of us, and that is what is happening. So, taking advantage of the disadvantage we had by way of the situation around, we started connecting the young generation to through these webinars, through this digital communication medium. And in that, I'm very proud and happy to share that the SESI student chapters we have at different institutions all over India. So we interacted with the SESI student chapter and the mentors to the student chapter, who are normally professor in different institutions. We interacted them and we requested them that why not to start something wherein we can ask the professors of different institutions who are studying in this field, they can come and talk to us, to the students who are joining us through the YouTube and all that. At the same time, we are also looking to interact or connect with the entrepreneurs, because the side has, there are two sides. One is academia and researchers, and the other is the industry, which is in the solar sector. So it is our endeavor to connect both through Solar Energy Society of India, and of course the main is solar. So taking it into consideration, we have uh, a separate wing which is interacting with industry, and we have another wing which is interacting with academia right now. And in the process ahead, we will bring both the together, and we'll try to be a catalyst or the facilitator between industry and institutions, so that whatever the institution is producing, the manpower, human manpower, human expertise, that can be of use to industry, or why not to develop an industry with the help of this human manpower. That is the thought in our mind. Keeping that thought, we appealed, and I am very happy for Dr. Soumarajan and other friends of him or colleagues of him. They responded well to our appeal, and now this is the one program we are starting from today, wherein we are trying to give a chance to our student chapters to organize these type of events, programs, interactions, so that more and more people can come together. And as there is a saying in a Sanskrit, vade vade jayate tato bodha. So if someone takes it into direct vade vade, so someone may think of confrontation, but it is not confrontation. It is the interaction between people, and by interacting, we can gain, we can develop, we can progress. So on that background, we have started, and that's why I am very happy for both of you, Dr. Somarajan and Professor Senthil, that you are the initiator for this program, and we hope that every week or once in a fortnight we will have this type of interaction, and that will be beneficial to those who are joining us through various mediums of social media available to us. Secondly, as the topic goes of today, the energy storage. This is the very important topic which you have chosen. Really, thing which is of tomorrow, I can say. And the most important thing is, earlier days we had a solar energy which is going to provide us the energy or input. We used to have illumination or LEDs or other facilities, those are there. We need a power or energy for that, but there was a big question on solar sector, that when sun is not available, you are of no use. So there, that big gap was there, and we are happy for energy storage, that whatever the solar energy is producing and in a daytime, and it is in excess of that, that can be stored with the various storage mediums that the Professor Senthil is going to discuss. And because of that, the question which was on the solar sector, that you are of no use when there is no sun available, that is going to address. And not only that, that is going to give us a big help in whatever the developments which were otherwise stuck, which were not happening there. So we can expect many more things because of this energy storage sector. And the way it is growing is really encouraging, and it gives us enthuse that yes, the world will be more and more better in years to come. So with this important topic you are touching today, I'm very glad for both of you, for your institutions. I'm also thankful to the institution SRM Institute, who are our partners today. Similarly, different institutions will be partner in this program, on every program, and we hope to continue this for a longer duration, and this will help to the students or whosoever, because now the things are not like that we are doing it for a student. Anyone, if you are a age of 50 and you have a mind to learn, then you can be a student, and then you can take advantage of such type of sessions. So we are trying to provide a facility with the help of my student chapters, and I am again thankful to all those mentors who are the professors in respective institutions, who are mentoring the group of students who are part of CSE student chapter at their institution. So thanking them again and wishing you all success. I welcome both of you and would like to ask you or request you to continue with the program. My all best wishes are with you again. Thank you.
Yes, thank you, sir.
Thank you, Mr. Praful Pathak, enlightening the participants on the advantages of solar energy and different wings of Solar Energy Society of India. Fortunately, we are also in the part of that society, and as a result, today we have a Solar Energy Society of India at SRM Institute of Science and Technology campus with more than 100 live members and many student members. So thank you for all the opportunity you gave to us. Today, we have Dr. R. Senthil with us as a speaker. Dr. R. Senthil has completed his BE and ME from University of Madras and Anna University in 1997 and 2000 respectively. He received his PhD degree from SRM Institute of Science and Technology in 2017. His area of interest is energy efficient building, solar energy utilization, and energy storage. He has published more than 60 research articles in international journals and conferences. So with this, I welcome Dr. Senthil R. Senthil to this program, and I also request him to address the virtual gathering. Thank you, sir, for joining with us. Please take over.
Yes, thank you, sir. Thank you for your well introduction, Sri Prabhula Padak sir and Somarjan sir. I will start the presentation. Yeah, today's topic is opportunities and challenges of solar energy storage. So, as Professor, Professor sir told, we long way we are working on how efficiently converting solar energy into our applications. Then now it is a need of the hour to think of storage for the long term. It's even off sunshine hours. So my presentation just starting about my intuition initially, then solar thermal system and its storage, then electrical system and its storage, then the challenges what we are facing on the energy storage side. So our intuition, it is around 50,000 plus full-time students across all the campus. Then campuses, then 3,000 plus faculty members are there. We are having different verticals. We are running programs EG, PG, and PhD and PDF, engineering technology, management, medicine, and health sciences, science humanities, law, and agricultural sciences. This is our SRM Katangaluttur campus. The overview. Before going to solar energy, I want to say some word about sustainable development goal. It is the affordable clean energy, the goal number 7. When you are working for the goal number 7, so whatever the work when you are working on solar energy conversion, utilization, or storage, and whatever, etc. So it is certainly focusing on the goal number 7. So when you are addressing the goal number 7, we are working on the goal number 7 for affordable clean energy. When we are working on this goal, we are able to address some of other key indicators of the other goals also. I will come back to later. So when you talk about this goal, the targets of this goal by 2030 to ensure universal access to affordable, reliable, and modern energy services. Then to increase substantially the share of renewable energy mix, including wind, solar, and biomass, etc. In the global energy mix. Then to double the global rate of improvement in energy efficiency, then technology updation, our thing towards clean energy and against climate change. Then some facts about United Nations Development Program. 1 in 7 people still lacks access to modern electricity. Then 40% of the population globally, they rely on wood and low-grade fuels or polluting fuels for cooking and heating purposes. Then regarding the employment, 20% of the power generation renewable as of 2017, but 10.3 million people got opportunities to work on the field. So it is not only providing energy and also providing the employment. Same way, it is the 60% of global energy greenhouse gases emission due to only energy exploration, energy generation. So if you're addressing this issue, when you're working on solar or renewable sources, we are able to minimize this global effect of greenhouse emissions. Then when you're working on solar energy, or when you talk about affordable energy goal number 7, it is addressing the good health and well-being because we are working to reduce the carbon emission. Then clean water. So our technologies are used for solar desalination making soil water into potable water. Then same way, decent work and economic growth. This is providing the opportunities and all the things for the economic development. Then sustainable cities and communities. So here, when you're utilizing solar energy or any energy, renewable energy conveniently for them efficiently, are able to provide good communities and societies with a good health and environment. Then responsible consumption and production. So this energy directly helping this aspect, then climate action finally. So these indicators, you are given numbers. These are the indicators are satisfied by when you are working on goal number 7. Same way when you are working on goal number 3, it can satisfy some leads to goal number 7. Then when we talk about solar radiation, the sun surface temperature is around 5,500 degrees Celsius. But when it's reaching on the earth, it is not reaching only 2 digit, around 20 or 30 degrees Celsius. So how it happens, that we will see first, then how to measure the radiation, then we can go to the different energy conversion and storages. So the sun surface temperature around 5,000 degrees Celsius. However, when you are reaching the surface, it is diluting, still diluting, and it is rating very low. When you talk about solar irradiance, any surface, not other radiation falling on that, it is a irradiance. When you talk about any horizontal flat surface, it's called insolation. When you are talking about any flat plate solar PV system, we can go for insolation as in the context. Then same way in our country, we are having 5,812 trillion kilowatt hour of solar radiation falling on the earth. Then we are getting about 4 to 7 kilowatt hour per meter square area. This is 7 in the Rajasthan, Gujarat, then 4 maybe other part of the country. So it's variable. Then the sunny days, we are blessed with good sunny days in a year, around 280 to 300 days. And compare the distribution of the country. Then our person are using 14 or 15% of generation usually by renewable, mainly solar and wind. Then when we talk about this radiation variation. So once we can say seasonal variation, the June 21 longest day and December 21 shortest day. During that time, the sun is almost above your head. So during that time, the radiation is passing shortest distance on the atmosphere. So we are having higher intensity value. But when you talk about December, it is traveling a long distance to reach our place. So it is very diluted. So this is the during summer, June, these are during winter. So these radiations are starting, just easily passing the atmosphere. We are getting higher intensity, here lower intensity. So most of the houses, not in urban climate now, I'm talking about earlier climate, the south facing windows are used to allow the sun rays to inside the room, inside the house, to warm up or to heat that one. So whenever the cold days, the sun high energy is used to enter. That's why the south facing windows, south facing houses are earlier days it is there, but due to the urban population, we are unable to maintain this type of solar geometry real time. Then regarding solar radiation, at the top of the atmosphere, it is around 1,366 watt per meter square. It is 1,000 plus watt per meter square on the surface of the atmosphere, but when it coming to the surface of the earth, it is around 1,000. It is variable. 1,000 is I'm out almost peak value. So the 1,000 watt per meter square, but here 1,366 watt per meter square. So that much lost because of the clouds and atmospheric particles. When you diffuse it, that is called diffuse radiation. It has a different component of the total radiation. Then beam radiation without deflecting or directly hitting the surface on the earth. So these two radiation we are adding, this is called a global radiation. Whenever any flat plate collector, PV collector, flat surface, we can account both the radiation. But whenever you are using optical type, convex, concave, just focusing collector, parameter collector, disc collector, central tower, or compound parabolic collector, or concentrated photovoltaic collector, we can account only beam radiation. So to find out the performance. Then regarding that variation in a day, how the beam radiation and diffuse radiation vary. From morning 6 to evening 6, we can say the diffuse radiation is almost same. It is around 100 to 200 watt per meter square. But the beam radiation keep on increasing via sun coming to top of our head. But during the sun, solar studies, we are saying sun is moving, but really sun is not moving. We are moving. But the movement of the sun, the variation is there. So this is the beam radiation value. Varies in a day. This one day I'm taken a value. Then this is the global radiation or total radiation. Is sum of these two. It is the total radiation. The total is used for any flat plate collector. We can go for this one. Then whenever any concentrated collectors, we can go for a beam radiation as accountable. Diffuse is not obeying the optical law. So beam radiation only accounted for any optical based solar systems. So these are the measurements before we go for any studies or any other utilization. We must measure, even we can have a pyranometer to measure the total radiation, then per kilometer long collimated tube, only the very smaller opening, so only the beam radiation only can enter. So here the sensing mechanism of EMF based on the EMF generated with calibrated value can produce what is the watt per meter square on the day. Then this is a sunshine recorder. Here a strip of papers are kept. Then based on the length of bunt, it is calibrated. So based on the length, 1 centimeter, 2 centimeter, we can say the daily active sunshine hour. Today it is 3 hour, very active. Then tomorrow maybe vary. So that can be done by sunshine recorder. Then anemometers are used to measure the velocity, because most of the solar systems are rooftop or top of the ground. So we need a velocity to check its thermohydraulic behavior. Then this is a hygrometer. Sometimes weather station is part of all the things. The weather station can have other components also. Then temperature measurements by the ambient temperature. These are important when you are dealing or quantifying the performance of the designed system, whether a solar energy thermal system or electrical systems. Then solar thermal system and its importance with the energy storage. So flat plate, mainly you can say two types. One is concentrating, other is non-concentrating. The non-concentrating absorb the global radiation, whether flat plate detector, solar dryer, evacuative collectors comes under non-concentrating. It means surface area of the collector and observer same. So there is concentration is 1. When you talk about single axis tracking, it is tracking east to west only. So this parabolic top collector and frontal collector both are tracking the sun east to west only, one direction. That is called it as a single axis tracking. Here the observer is a line observer. So what are the rays falling on that? Even the different mirror strips are having different angle to focus always on the single observer. So this is used for power generation normally. Then dual axis tracking. This tracking, it is a east to west tracking also done, as well as seasonal tracking. I told about the June 21 and December 21. During that time, every day, once in 3 to 5 days, the sun is moving up or down based on when you're coming to apex or when going to horizon. So that movement also done, that concentrated is some tilting of this, that is called north to south. So this is called a two-way axis tracking, disc collector, then central tower board. Here large helios mirrors are there, maybe 2,000, 3,000 mirrors are there, each maybe 2 feet by 3 feet size. So these mirrors are, each mirrors are tilted the different angle to focus only one single point observer. So these disc collector and tower collectors are having point type of observer, but these frontal as well as trough, it is having line observer, but this is observer or surface only, the surface absorption. So based on this absorption, the high temperatures are based on the focus, you can have to achieve very high temperature, because the concentration ratio increases when you travel from a very flat plate to tower collector. So with the observer area and the collector area same, it is concentration 1. It is applicable for flat plate, PV, other things. Then the trough collector, parabolic trough collector or the personal collector. This blue color is the area of the reflector, then this is the observer area. So the total area of the reflector by observer area is giving a higher value than 1. It is comes around up to 20 to 30. So it is having higher temperature around 300 to 400 Celsius. Same way here, the top collector or disc collector, disc collector or central tower collector. Here, these mirrors are focusing on small observer, so we are getting very high temperature. This is a very high, higher concentration, very high, so we are able to get high temperature, but not up to sun surface temperature. We can go for 4,000 or that is not possible up to sun temperature. Ideally, the opticals are having losses, so we are not able to get same sun surface temperature. Not possible. So this is used for power generation, these high temperatures. Then most of the applications, if you see pharmaceutical, textile, chemical, food process, wherever, all the industries, it may require a superheated air, here's hot air or hot water or steam. Even the temperature requirements are capable of producing by using the before mentioned solar collectors. Same, when you go for materials, because when you talk about the solar energy system, thermal system, materials are important. When you go for low temperature, it is highly conductive, thin materials, copper, aluminum. This type of things important for conducting the heat faster or absorbing the heat faster. Then thickness should be very thin for low temperature system. Then medium temperature, it should have high temperature resistance, so we can go for the steel or ceramic based collectors. Then reflectors are always highly polished mirrors or maybe metal sheets to reflect maximum. So it should have around 0.9 reflectivity for the better solar installations. Then reflectors should be selective coatings. The coating is important. The absorption should be more than 0.85. Then only whatever the radiation falling, it can absorb, it can transfer to the working fluid or the fluid or any solar medium inside that one. The same way heat transfer medium, for the low temperature, we can go for refrigerant or water and all. When the water normally used for sensible heat as well as when you are going for power plant also. Then thermic oils that are more than a degree. Then molten salt, then sand particles. These are very high temperature. It is used in central tower power plant. Then insulation, it is important. Based on the temperature, we can go for different insulation and different thickness. Then support structure are important because most of structures are outdoor. Also, it has to calculate again the wind load to safeguard the system for its life duration. Then foundation and different structure. Wind load should be accounted in the particular field, particular place. We have to account the maximum wind load. For example, during the cyclone, they are saying some velocity. So this much velocity is coming. So that velocity of the wind to be accounted when you are installing a system at a central place. Then sensible heat storage normally the steel, stones, pebbles, then water, oil, many things. Then heat transfer fluid should have highly thermal conductivity, then diffusion, then mass density because it store more energy or transfer more energy based on that. Then low specific heat value. Viscous should be low to reduce the pumping power. Then non-corrosive because we are recirculating again and again. Sometimes the water is getting phase change in the evaporator, it is getting vaporing. Then the condenser it is getting. So in terms of absorber, it is getting vapor. Then other part of that turbine or out of the turbine, the power generation, it is getting to water again. So this phase change should have no corrosive. Same way, phase change is a transit limit. So whenever it is becoming water or vapor or whenever liquid and solid, if the temperature limit should be in safe limit, it shouldn't go beyond its critical limit. So otherwise, it can damage the system or will lose the energy, I mean the material everything. Then long-term stability, whether the fluids, then same way cost space, then other things. Then was a few examples. So here you can see the solar furnace, the largest one, the Odilo, it's constructed in 1970. You think of that, how long it is. Then it is generating up to 4,000 degrees Celsius. Now we can visualize this is a larger reflector. Then so many reflectors are here also. So this is focusing on this reflector. Then this is again focusing on the small observer. These are tower. So here reflectors are there. Then one more big concentrator. So this reflector reflecting this one, they are acting as a primary as a secondary. So because of these so many reflection, we are able to achieve 4,000. Almost we are going closer to sun temperature. Then another one, when you talk about the fuel generation, whether you can go for the pyrolysis, gasification, or water splitting, or hydrogen generation, or fuel cell application. There are larger mirrors are there. It is a central tower. At the one particular observer side, here all the mirrors are having different angle, tilted, but it's always focusing on this one. So even the sun moving, then these mirrors are tracking on this particular region. So we're able to produce high temperature, even it is used for green hydrogen production. So these are one of the, even we are meeting almost all the heating, cooling, power needs. Nowadays, we are working on producing fuels also using solar energy. So almost all the field, it is possible. Then regarding energy storage, we are having mechanical energy storage, pumped hydro, it is a long-term storage, compressor also long-term storage. Then flywheel is short-term storage in terms of engine. Within one rotation is getting power, other three rotations are no power. So it is producing, storing at the start moment. Then same is sensible latent heat transfer, medium level storages. Then supercapacitors, then magnetic storages. These shortest but highest energy storages. Then hydrogen is one of the longest energy storage when you are going for thermochemical, electrochemical. Even you can use photovoltaic system, photovoltaic energy, or even thermal energy to bring hydrogen from the water. You bring out the hydrogen from the water. Then flow batteries, electrolyte based batteries. Then these batteries normally lithium. This is the lithium is the most popular now. Even majority of the electric vehicle that the type of transport 60% they're using, and the remaining is using power as well as other medicines. So regarding thermal energy storage, we can say by nature of how it is storing energy, by raising temperature is storing, it is called a sensible heat. By storing the energy by phase change, this is the ice. Ice is the largest storage in the world. In the polar region, Antarctic, ice storage. We heard about that one. So north or south, it is completely ice. This is the ice is the largest storage. It is nothing but phase change. When you are melting ice or when you are freezing water into ice, it is storing 353 kilojoule per kg. So this is a type of thing. Even paraffin wax mostly researched by several researchers are used in many places. Because it's cheap and cost, then it is good compatible with the materials, conductive material. So this is by changing its space at the utmost isothermal temperature, it is storing energy. So it is compact in size, around 5 to 10 times smaller when you talk about these sensible heat storage, like pebbles or oil or water. Then thermochemical, it is changing without changing temperature, but it is changing the pace or changing to other molecule. Then it come back when you are retaining the heat. Then base and materials are normally, it may be organic, inorganic, or even atopic, maybe combination of 2 organic or 3 organic, or maybe organic and inorganic, vice versa. So the charging means when you are melting, when you are high temperature PCMs. Normally the cold storage also PCM, but there we are freezing the water into ice, we are storing energy for peak time. So whenever the lean time, we are storing the electricity, in terms of ice. Then whenever peak time, when peak demand, electricity demand, that time we are releasing the heat from the ice. So that is one of the ice storage. That time we are storing energy below the room temperature. But when you talk about that time, it is water into ice, solid into liquid into ice, it is storage. When you talk about high temperature system, if you are using in flat bed collector, a water heater, then melting the paraffin wax is the charging. So charging completely means the whatever the mass of PCM, we are having a 5 kg or 2 kg, it completely become liquid. That is called charging. The discharging, whenever our demand, low temperature region, that time we can demand, just pass the cold water, we will release the heat from the stored PCM. Then it's normally 5 to 40 times higher energy density. Then it should be encapsulated because the PSI metals are normally chemical. It having poor thermoconductivity. It's not like a metal. So metals are sensible type. They are conducting faster, but they're not storing much. But here it is conducting slow, but it is storing more energy per kg. So here we need to make the proper sizing of the PSI material. If you're putting a 10 mm thick, it may melt differently. If you're putting 5 mm thick, it may melt differently. If you put 100, based on the thickness, it can melt faster, or it may not completely melt and charge, or it can store energy. So it may act as a sensible instead of acting later. So we need to size that one. That's why the encapsulation is important. Then low temperature storage mediums are ice, slurry, seasonal storages. Seasonal means one season where it's very cold, 5 degree or minus 5 degree, you can store the energy in the soil. Then later season or daytime, whenever the peak radiation comes, that time we can use that cold energy. So that type of storage these are applicable in our part of the country. Then room temperature to medium temperature are like paraffin, wax, fatty acids, sugar alcohols. These are the good organic PCI materials. Then same way high temperature nitrates, carbonates, these are all useful for that one. Even liquid metals also. It may be, I already told you, PCM may be, PCI materials are organic, inorganic, atopic. Atopic means any combination. Then we expect higher energy density, but it should not be always there. So we have to go for additives for the property. Same with the metal, suitable with temperature. Our application requires 65 degrees Celsius, but normally the market, the patient will be available 60 or 70. Then you have to add to PCM, you combine 60-40 ratio or 50-50 ratio. You have to alter the property. You have to synthesize a patient material to bring out a 60 degree melting point PCM. So that is one of the thing. Then you have to use the suitable melting temperature. When your application requires 50 degrees Celsius, you have to store at least 55 or 60. Don't store at 100 degrees. So otherwise it can lose the energy to surrounding. So the stability, that is important. So whenever operating, the PCM undergoes a repeated cycle, 1000 or 2000 cycles. So it should be within the limit of decomposition limit. Otherwise, it will not retain that storage property. That should be higher thermality. It is not having. So we are going for nano additives or carbon additives, graphene additives to improve the property. Or we are adding some other sensible heating also. As a combined concept, we are improving the property of patient materials. Then this chart given by McLean and Kapisa, it will be useful to select when our temperature range is here. Then how we can select this temperature, we can go for around less than 100, we can go for sugar alcohol, paraffin, salt hydrates. When you go for high temperature 300, you can go for nitrate or hydroxide. Same way, this is the temperature, operating temperature, melting temperature of PCM. It may procedurally, you can choose for the application matching temperature. That same way here, enthalpy also rising per meter cube. So when you go for here, the size of the container will be lesser. When you go for here, you can go for high temperature applications. The same way here, the heat capacity, the heat storage capacity per meter cube. This is the trend. These are mostly used PSI materials, sugar alcohol, organic materials, molten salt, metals. These are all used. The lithium based things are normally costlier. It having working at high temperature as well as good enthalpy energy storage. Then bottom line, there's sodium hydroxide, then nitrates, these type are there. In the medium, the sugar alcohols, paraffin, fatty acids are there. Same way cost wise, when you say the cost per kilowatt hour, this is the melting temperature, this is the cost. So if you go for the along this, the top is a high cost, here is a low cost. So these regions are having more popular for the researchers. Or the when you talk about application, it should have a low cost, then only the consumer will prefer. So these are the regions, the PCM mostly researched are mostly used in the real-time applications. Then one real challenge. Some materials, thermochemical, thermophysical, some passage are the thermochemical storage. Some may have lighter in weight, some may have in compact. One is weight wise, one is size wise. So when you are combining these two PCM, you are able to produce some passage material, electric PCM or some combination. They are able to bring here. It may have light in weight and size also compact. So these are the area. It is vacant now. The most of the people are working on that. So when you are able to come here, like a lithium-ion battery, thermal storage battery also, it can rule the world. And then when we say about passage materials, a lot of issues are there, challenges are there. These are the opportunities. You can add pins, heat pipes, multiple cascade passage material. Instead of storing one, you can store more or two. We can reduce the degradation or loss of entropy, so that is possible. Then encapsulation, different methods are there. We are able to work on this by any one or two methods. You can improve the property, make the feasible, reliable for the real-time applications. So different mechanism, how tubular, spherical, different shapes we are used. Because why we are inscripting, we make a smaller one, it can completely charge or completely melt. If a thicker one, it won't melt completely. So it may act partly latent heat, partly sensible heat. So to avoid that one, we are going for encapsulation. There are different methods. There are different applications, how we are encapsulating, how we are improving using pins or other packages. Then safety, when you are using the passage material, basically chemical, we have to choose the container material which should be compatible. If you are using copper and paraffin wax, it may have issue. I mean, it may have perform better. But if you choose paraffin wax and the aluminum, definitely get corrode after a few weeks of different repeated cycles. So we have to bother about that compatibility with the container material and working fluid, as well as this safety thing. We should not overheat the passage material to destroy its properties. Then different applications of storages, flat pile factors are evacuatable as a water heater. We can store for later time because we need hot water in the morning, but unfortunately solar rays are available during noon time maximum. So we can store in the energy storage, sensible heat or lateral heat. Relationships are bulkier storages, so lateral heats are preferable in combatant size and storing more energy at a smaller volume. Then can be used for postponing that hot water and the heat demand, even night time or morning possible. Then solar ponds, it is used normally for generating power or storing energy in the water. Then swimming pools, even colder climates, it is very difficult to go to swimming pools in the morning. So we can have the passage materials embedded in the bottom of the swimming pool. It can provide the warm effect during the morning time. Then solar cooking, whether it is smaller box cooking or disk cooking, this type of cooking, we can store the energy or we can warm up the food for a longer time using thermal storage. Same way solar assist air conditioning, normally space heating or dryers, we can go for energy storage integrated. We can prolong the time or we can extend the working hour of the even 24-hour continuously possible. Then solar PV and thermal system, normally cooling of PV. The cooling of PV, it won't raise maximum power, but it can have byproduct, the heat, hot air or hot water. That is one of the major advantage. So even several claims are that the PV power is increasing, but one thing, the PV life is increasing and the hot water and hot air is getting, that is the additional advantage for us. The same area, same investment, but with little more investment, we are able to get hot water or hot air. That is one of the advantages of PVT systems. The natural process heating, whether using top or disk collector, we can go for steam for heating, the same way power generation. Then thermal management of building, how effectively we are using energy, because most of the energy is consumed in the building only, whether cooling the room or heating the room or lighting, that purpose only. So we can go for solar chimney effect to maintain the low temperature of the room, trombone atmosphere. Sometimes you can want to heat the room in the cold climates or countries, we can go for that. Light pipes, even wherever the visible to sun opening is there, from there, like periscope principle, we can bring that one inside the room or wherever it is, even though there is no direct roof. then natural lighting. Then hybrid energy system, normally it can go hand or retrofitting, it can perform better. Any solar energy system. Then heat recovery system, whether conventional system, we can go for energy storage, greenhouses. Then ice and cold storage, solar vapor absorption for cooling and air conditioning. Then thermal managed electronics, batteries, that are all possible using thermal energy storage. So these are different storages, solar steels and solar dryers. We are able to place energy storage indirect to the collector. They are able to get more productivity. Same way, the PV based systems or Trombay module system, we are able to maintain the lower temperature inside the room. Then one of the best example, 15 hours of energy storage using molten salt. This is the largest central power plant. They're able to store 15 hours, almost they are running 24 hours the plant because of the molten salt storage. So it can show you the importance of thermal energy storage. With that, I'm going to solar PV systems. Here, this is the energy potential. So the very highest potential, this is the dark color. Then this is the highest potential countries. Then these are around 40 countries are already they are doing good business in solar. They are having more than 1 gigawatt power plant. So more than 1 gigawatt solar PV power plant, they installed these regular areas. So almost 40 countries are already there good in solar. Even they are working better to make 50% or 100% in near future. So this is the share, how solar installation and the cumulative installation. So we are in 5th place in cumulative. Then we are in the 1 year in the 2019, we are the 3rd place. Regarding the PV, first is silicon based cells are there. Then thin film cells are there, it is non-silicon based. Then new generation cells are there. So mono cells, it is having a highly competitive, having good efficiency for the longer period, even 20-23 years. It is performing better than polycrystalline. However, cost-wise, performance-wise, it is competitive. Then cadmium telluride and CAS cells, copper, indium, selenium cells are these cells are thin film cells. These also a lot of this is going on. Even market also some they reach the market. Same way organic solar cells like dye sensitive solar cells, then perovskite solar cells, then concentrated PV. Here the concentration is coming. As of now, all the thing it is operating the global radiation or total radiation, but only this concentrated PV it is operating the beam radiation. So we are using lenses, mirrors to focus on smaller area. Here the multi-junction, we are having PNP like that, we have different channels, we are able to get higher electricity conversion using this multi-junction. Then quantum dot solar basically nanoparticle paired. So regarding the efficiency, when you're testing it as per IEC standard or STM standard, the air mass in the noon time, the air mass is 1, the morning it is 2, around 10 o'clock is 1.5. So the air mass 1.5 means it is taking the average. It should have noon, it should have morning, evening, they're taking the average. That air mass of 1.5, then air mass means is in a traveling, length of travel of rays in the atmosphere. So that condition and 1000 watt per meter square condition, the cell temperature is maintained 20 degrees. So at this condition, this is the lab level or cell level or module level. But real time, when you go for module level or by plant level, it may perform slightly lower. But these are the record efficiencies as on 2020. Silicon around 26. Gallium arsenide 3 to 4 junction 19%, silicon amorphous 10%, dye sensitive solar cells are around 12%, organic cells are 15%, perovskite 24, and 5th junction and 5 junction based multi junction 47. These are the highest record efficiency, but not on the real time scale. But it is a laboratory or model level that's successful. On the smaller size of the cell, it is successful. But when you go for larger size, larger real time system, it may have smaller dig on that. When you talk about battery system, the lithium ion is rolling because it is lighter in weight and smaller in compact in size. So it is storing more energy, watt-hour per kilogram of the mass. So it is storing more energy as a lighter in weight and smaller in size. So other batteries also there, lithium, nickel based, other gel are lithium based. Then when you talk about lithium carbonate based batteries, phone it is having around 10 to 20 gram, laptop around 100 gram, hybrid systems are up to 5 kg. Then like that, the behind the meter is important. The behind the meter, whatever they are using in our house is the behind the meter. Then electric vehicles are taking 100 kg. So these are the mass other one. Front of the meter, this is the utility side. These are power generation people. They will use battery energy storage for this is the front of the meter storage. FTM batteries. This is the BTM is household or consumer side or demand side. This is the supply side batteries. So these are the mass of lithium requirement. And same way, how the lithium prices are down because it is having good in demand. So when it goes high demand, then we have to see in 25 or 30 what happened. We have to see. Then this is before the meter. It means this is a meter. Before means after generation we are using batteries. Iterative battery in large scale level. We can store. We can manage the supply side. You can store the battery. You can reduce the peak time demand or peak time power generation. Are able to manage. Same way here, consumer side. After the meter, we can have the battery to for backup power or our comfort. This one shares from the energy meter coming to battery, then to application. If you are using renewable energy, it can give directly to battery, or whenever excess can give to the battery. Whenever actually they consume, it can directly use for consumption. So that this is the thing used for behind the battery, almost demand side. Then how it is conserved energies. So it is a great purchase. During that time, very high radiation, the energy is stored in the battery, then it can be used in the night time or any time. So this is a load balancing using BTM behind the meter batteries, especially is for consumer side. Then based on battery storage capacity, we can say domestic level, commercial level, or utility scale. It may be around 3 to 5 hour. It is a BTM behind the meter battery. Then FTM battery is also there. It makes more than that. Then benefits increase self-consumption and backup power, electricity savings and demand charge regulation, frequency regulation, peak capacity can be avoided. Then replacing DG sets if you are using a BTM or FTM battery. Then smoothing of the variable. This is the important aspect. Whenever variable renewable energy, whether wind or solar, it is not constant sources. It is variable throughout the day, every minute, every second. So that is the real challenges. That time the batteries, whether FTM or BTM, it can help us to maintain our healthy living. Lithium batteries produce higher density, improved resiliency, and longer cycle life. That's why it is most research or most people are working on that. Then the issues are variable nature of energy storage, that is not reliable. So we have to go for storage to match that one. The same is source demand type match, grid stability. The integration with the other renewable sources. When you are using the other sources or other plants, any retrofitting, we can go for energy storage. So same way, solar energy systems are end of life management. This is important challenges. So whatever thermal system or PV system or any storage system, end of life management is very, very important, because now if you see the dumping of medical waste as well as the electronic waste, computers or computer peripherals, it is heavier in market. Same way, we are also threatening to the atmosphere. So end of life management is important, whether the PV, battery, or whatever it is. So the type of challenges are there. We can work. It may be a good lucrative business in later stage. Used to be buyback. Whenever 20 years over, 30 years over, or maybe 10 years over, next to the same area, they are producing 500 watts panel. And earlier we are buying 250 watts panel. Within 2-3 years, the technology developed, they are producing same manufacturer 500 watt panel, same area. Then instead of adding 2, we can give the 2 panels to them. Then we can get 1 panel. We can have more area for more purposes. Decoding performance are important, whether energy systems or storage system. Monitoring management is important by using advanced technology, IoT, blockchain. Other thing we can use for cloud data. You can go for a lot of opportunities when you are maintaining these things. Same as standard testing and certifications are lacking. Stability of the performance and enable additives for anything, energy storage. Real-time stable performance of new process are real challenge. Then energy storage based on solar power generation and process heating possible. Then solar fuels, especially hydrogen generation. So it may have a good future. Then solar based CO2 capture, urea formation. This type of carbon capture also, clean mechanism also possible using solar energy. There solar PV or solar thermal route. Same hybrid energy system, fuel cell, geothermal, any other combination possible. Same way building related photovoltaic or PVT systems, you can produce simultaneously electricity as well as power. Then bio-inspired solar cells, we can imitate the bio, how the leaves are working, how the butterflies having that lighting effect, how it is absorbing energy. So that and all we can follow. We will produce bio-inspired solar cells. It is completely organic. There is no issue. Then floating and immersive PV. This is important because land is the issue now. We can go for floating or immersing under ocean or clean lake water. This is one of the possible areas of going on. Then smart grids and load shifting. This is important when you are using energy storage. This can be managed or maintained. The zero energy buildings are important when you are using solar energy wisely for lighting, for cooling and heating, then electricity. Then extend the solar energy technologies to every field is possible. You can think of solar cooking, heating, hot water, steam bathing, then medical sterilization, any autoclave, any application is possible. Then blood, so different other technologies also required to maintain to make perfect on this one. So regarding solar energy, I came to end how the SRM is fighting the climate change, how we are working again, are working forward, are working towards the SDG 7. So we are having several almost targets 1 megawatt for the power plant. We are having different installations are in our building. I'm showing 1 or 2 glimpses. It is 100 kilowatt on university building. Then several other buildings are there. Sometimes having some space, even any terrain on the roof also. Sometimes on the slope, they are keeping on some spaces also. So what are the possible things they are using? When the students are able to learn how the airflow can cool the panel, whether it's on the roof or having 1 feet height or maybe 2 feet height. The general students are studying. This is the overall view from one side of the campus. Here, solar PV, wherever you see the rooftop, wherever the space, the PV are placed. Then regarding power generation, we are having 100 is the target, 1 gigawatt and 1 megawatt is target. We reached the 863 kilowatt now. Due to last 1.5 year pandemic, we are slow in this process. But however, within a short period, we will reach 1,000 plus kilowatt. Then as of now, we are sharing 20% of the energy consumption by whatever we are producing using solar energy. So we are doing good business on solar, and we are reducing the CO2 emission. We are providing cleaner environment to our students and staffs. Then another plant in the Tirupati, the SRM is installed and maintaining 100 kilowatt. It is almost 6 years of operation. It is 6,000 plus units of electricity generated every year. Every year, how much energy generated during using this plant. We are maintaining this one. This also we are contributing to the society. Then regarding solar steam cooking, we are having large mirrors of 16 meters square parabolic disc collector. It is Cheffer type collector in our hostel steam cooking plant. We are having 37 collectors and few collectors for especially for research purposes. So we are able to reduce 5% of the fuel consumption. Instead of burning this much of LPG cylinder, we are able to save around 600 to 800 cylinders in a year. So this much carbon mitigation we are doing in our campus. Then these are the certification from the MNRE for the best operating plan or best maintenance plans. We are got the awards. Then these are the disc collector for research purpose. There are many people are working on modifying the observer and getting more energy, because this is the reflector size, this is the observer size. This area with this area, the concentration, it is around 100 times you are concentrating. So how the small modification can affect for different application? We have done a lot of work on that. There are different modified observers are there. Then our students are working on various work projects. So because of time constraint, so all the things I'm showing on per disc collector with the storage cooking, then the indoor setup, indoor PV setup, indoor thermal setup, then solar dryer, then PV and PV cooling. They are using hot water and water and air, so they are getting hot air and hot water as a byproduct. But the efficiency is almost little higher, but not much variation on the electrical purpose, but performance. But these cooling aspect is producing more longer life of the panel, as well as they're getting byproduct hot air, hot water. Then this is the same way water heater as well as air heater, a single system. Then this is the simultaneous testing of 2 type of solar dryer system. I'm giving 1 or 2 samples only, not showing all the things. Same way this one. Then how we are performing on energy storage as well as solar energy research. Regarding solar energy research from last 10 years, last year we published around 312 publications in Scopus Index journals. So now, as of now, almost 50% of the year we reached it, but we are 223. So certainly we will have more, reach more than that. Here, every people, even physics, chemistry, chemical engineering, electrical engineering, civil engineering, everybody is working on solar in their projects, even water treatment, all the process, clean environment. So everywhere we are using solar energy completely in our campus. So we are able to publish this much high quality publications in every year. If you see the trend, it is keep on increasing, almost exponentially increasing. I believe this year also can surpass this 312 mark. Then regarding the thermal storage, we are working on cold storage as well as hot storage, heat storage, and electrical storage also. But when we talk about only thermal storage, we are in the 3rd position in terms of Scopus indexed publications. So University and IIT Delhi, the 3rd is the SRM University. The same way, we talk about fire disc collector. This is one of the flagship area we people are working on that. Even I am also belonging that one. We are the number one in the world in terms of scopus in the publication. Recently, we are doing a lot of research on that. So we're able to climb on the ladder. So there are highest publication on this character. Out of 1,579, we are able to put now 38. So then regarding the clean campus, we had the good awards and all for that one. SDG 6 clean water, we are getting 6th rank in the national level, then 51 in the world level. Same way, and as above energy, clean energy, then sustainable cities and water cities, compulsory goal, we have to go for ranking. All three are optional. So all are ranking within 10th rank. Same way, we have a good rank in QA Green Metric Award. This also we have achieved. Then these are the references. Yeah, thank you, Anandal. You can questions you can ask us. We will clarify that.
Thank you, Dr. R. Senthil, for your nice talk and enlightening our participants on different aspect of solar energy, starting from PV energy, thermal energy. So I think within a very short period of time, you could achieve, you could elaborate a very broad range of things, and it will be very helpful for beginners and as well as those who are doing research in the field. It will be very helpful for them. They can get a compact idea of solar energy research and education. So we are also happy to know that SRM University like not behind fighting against climate change. And if you see in SRM University, many departments, many people are working on solar cell,
Yes.
and it's a good standard all over the world. It's an international standard research is going on there. So thank you, sir. Thank you for your insight. I will request all the participants. Now this forum is open for the participant. If you have any queries, you can ask or raise your hand. Or if those who are live in YouTube, they can post their questions in YouTube too also. So any question from anyone, participants? Sir, I have one or two queries. Like if you use solar concentrator,
Yes, sir.
how we are going to manage the cell temperature, because it will enhance the temperature of the cell. So if you are using solar concentrator, then how it is going to help maintain the cell temperature?
Yeah, when you are going for concentrator, they are using multi-junction. It is not a one junction. If you use only one PM, it will burn out. So we are going for multi-junction, different layers. It can different temperature it can withstand. So the different layer multi-junction only producing power in terms of concentrator photovoltaic. But other even it can have a cooling system. It can generate a byproduct heat and heat also. But normal cells not possible to concentrate. When you're concentrating, localized concentrating, it may disturb the cell structure or the silicon material as well as the circuits. So only for especially multi-junctions possible, tandem cells are possible.
Okay, thank you, sir. Sir, one more question is like, what is the future of solar cooker and solar water heater? I think solar water heater we can see in many restaurants, many everywhere we can see solar water heater. But you cannot see like everywhere solar cooker.
Yeah, solar cookers are slower in performance, thermal performance. Then it is outdoor cooking, so the people won't like that one. So it is one thing aesthetic, other one is the familiarity and other thing. So when you are able to produce the highly efficient cooker, definitely it can reach again the market. Earlier it started, but it is unable to
cope up with the market. Yes.
Yeah, but one thing, based on seeing the fuel prices are increasing, the LPG, everything, definitely will. Same time, where people are working on to reduce the cost as well as everything, all aspects, the kind of better cooking methods. Then it is possible. Whenever the break-in point comes, then it catches the market.
I think from one participant, one question is there: why is not thermolysis of water for green hydrogen as popular as electrolysis of water?
Yes,
It is there in chat box.
Yeah, thermal cracking, it requires a temperature and you have to maintain the temperature. So by using solar, they are unable to maintain around 5 degrees Celsius throughout the process. So due to variable thing. However, now the energy storage is integrated with the observer or either any system. Now they are able to come. If you see a lot of articles also nowadays coming on solar thermal route, but the electrical route is passive easier because you are directly getting electricity. Then you are using for thermoelectrical process. So that is normally they done thermoelectric concept. But even thermal also, various research are working on that. The reason is one is already well proven, other one is ongoing research.
So any question from
Yes, the next step.
audience? I think we can see, sir, what is the future of solar power cars? Sir?
Yes, sir. Solar.
Yes. So, what is the future of solar powered cars? Like for the solar, you can
Yes,
say
yes.
car.
Yeah, solar. Yeah, solar powered car means depends upon the battery, especially nowadays lithium-ion battery. Now there is no battery matching its performance, so it is you know talk of the town. So when we see the lithium battery market is keep on reducing, minimizing, then efficient charging faster using variable renewable sources, then we can go ahead because the electrical vehicle and lithium battery is already same. Then how it is going hand in hand with the solar, then based on it how it is fast charging, then how it is reliable. So that one. So definitely once the EV is coming into market, then the PV based cars are popular. So we are waiting for that. Once that comes, then wherever we can have the largest battery, can store energy, you can give a higher rating of capacitance. You can charge the EV faster rate. So that is the thing. So directly only running on solar is not possible. It should run with the battery. Then solar is as a substitute or cannot just charging the battery. That is possible.
In other words, we can also say like solar power charging station also we can are there.
Yeah, that's right.
Yes.
Yeah, because once this is booming, then that will come automatically. When more
Auto
diesel cars, more diesel petrol pumps. Same way, when more EV, then that is a possibility. When wherever
Thank you.
solar is possible. Wherever wind is there, then from wind we can charge the car. Like that is.
Yes. One more question from Praveen Kumar showed why CSP solutions
Yes.
have not been able to catch up in India compared to other countries.
The solutions, eh?
CSP solution.
Oh,
CSP
CSP. Yes,
solution.
yes, yes. CSP. One thing, when the solar PV comes into picture, that the CSP looks, it is a highly high cost maintenance. So a lot of aspect. It is space constraint. So that one, the reason it is overtaking this one. Earlier, the solar CSP only started, but based on its installation, maintenance, and cost aspect, and the transportation, all the aspect, so it is not becoming a boom. Then the PV came into picture. PV is a convenient form and no maintenance required. Anybody can install their own. Lot of advisors are there. Everybody's different installers are there. Small capacity, largest capacity. Because of PV market, the solar CSP is in dull position now. Anyway, it is
One more.
possible. Yes.
Yes. I think he would have got his answer. One more question. What are commercial implications of deploying more CSP?
Yes, similar only. Cost and space
Yes.
and maintenance. That are the major aspect because these constraints are there. Cost constraints, space constraints. So these are important. But however, the CSPs are producing around 60% 70% of energy conversion there. Then around 40% of electricity possible from solar to electricity. When compared to the 23% or 15% of the solar PV at the plant level.
So any more question? So I think these are all the questions from participant side. Thank you, sir. Thank you for addressing all the queries of participants and delivering a broad knowledge to from very basic beginning to research aspect of the solar energy and storage. So I'd also thank to Mr. Prafullo Patak for giving us such type of uh, first of its kind type. We can say this is like very fast we have started, uh, and I hope in coming week also and coming months also we will arrange a different aspect of solar energy webinars. It may be from industry sides, from our alumni, those who are also now entrepreneur in solar energy. We will bring them to the front, and we will uh, uh, make this solar go more easier. So thank you all of you. Thank you, Professor. Thank you, Dr.
Thank you, Dr. Soumyarajan, and I am sure that whatever we have started today will go long way, and definitely all of you there at SRM and other institutions which are associated with SESI, you will continue this. Not only that, I wish we can add more and more like-minded people in our district so that we can go ahead and progress and work for everyone's better life. Thank you.
Yes, thank you.
Thank you, all the participants. I think it's time to uh, wind up the meeting, wind up the webinar. So thank you